So the first part, so phi times vector v will simply be given by x, y, z. You multiply by the vector xi plus x squared yj minus 3x cubed k. So we are going to multiply this value x, y, z to each component of these three vectors I, j, and k. So this will be x squared yz I plus x power 3 y squared zj minus 3 x power 4 yzk. So this is the phi times vector v. After defining phi v, then second part is to find the partial derivative of this vector with respect to x. So partial x of phi v is equals to, now this one, when you differentiate with respect to x, you get 2xyz I. This will get 3x squared y squared z j. This will get minus 12 x power 3 yz k. And then next is to find partial phi partial x. Partial phi partial x is simply partial x. Phi itself is x, y, z. When you work out this one, you get yz. And then number 4, partial v partial x. Partial v partial x is the same as partial x. Now the v vector is given by 3, is given by xi, and then plus x squared yj, and then minus 3x cubed k. Which will be given by I plus 2xyj minus 9x squared k. So that is what provides the value for partial v and partial x. Now, we have been asked to deduce from our result that if you find partial x of the product of phi and v, it's the same as taking phi multiplying by partial v partial x plus partial phi partial x multiplied by vector v. Now, to answer that part, I will say, also left-hand side is given by partial x of phi v. We have found our answer to be given by 2x yz I plus 3x squared y squared z j minus 12 x cubed yzk. Now the right hand side of that expression is given by phi partial v partial x plus partial phi partial x times v. So I just want to replace directly. Phi in this question is given by x, y, z. And then from our calculation, partial v partial x, we found our answer to be I plus 2x yj minus 9x squared k. And then partial phi partial x, from our computation, we found our answer to be yz. And then vector v from the equation is given by xi, then plus x squared yj, and then minus 3x squared k. So the thing is to open brackets and simplify and check that the final answer will be exactly the same as what you have on the left-hand side. So this will be x, y, z, I plus this by this will get 2x squared y, z squared y, so x is squared and also y is squared, j, and then minus 9x power 3 yzk plus x, y, z, I. This by this will have plus x squared y squared zj. This term by this term will be minus 3x squared yz k. Now bringing like vectors together, we'll get x, y, z, I plus x, y, z, I. There are the two of them. So 2x, y, z, I. And then 2x squared y squared zj plus x squared y squared zj. There'll be three of them. And then minus 9x cubed y z k. And then this is given by, remember this x squared and x, this was y z multiplied by x squared. Okay, this the value for partial phi and then partial v partial x from our computation, partial v partial x, I just confirm this was minus 9x squared, minus 9x squared. Okay, so by x, y, z, so this, okay, and then this at x, y, z, which is the value of partial phi partial x, and then multiplied by v, which was given by, remember this is minus 3x power 3. The power here is 3. So therefore, this ought to have been 3, this point here. So that now this power is 3. Now, minus 3x cubed yzk minus 9x cubed yzk, there will be 12 of them. And you can clearly see that left-hand side is the same as right-hand side. All of them are giving 2x, y, z, I plus 3x squared, y squared, z, j minus 12x cubed y, z, k. So i.e., when you work out partial x of phi v, you get phi partial v partial x plus partial phi partial x multiplied by v. Actually, this result can as well be proven by just general scalar phi and a general vector v without necessarily specifying the actual values. These are true results in general. And then another example. Number 2, given that if phi of x, y, z is given by x, y squared, z, and we have a vector v given by xzi minus x, y squared j plus yz squared k, find third partial derivative partial x squared partial z of phi v at the point 2 minus 1, 1. Now, the first thing that you're supposed to do in this case is to find phi times v. So solution, phi times v will be given by x, y squared z multiplied by x, z I minus xy squared j plus y z squared k. And when you multiply, you get phi v is given by x squared, y squared, z I, this also squared, and then minus x squared, y squared, zj plus x, y power 3, z power 3, and then k. What you're doing is simply multiplying each component of these three vectors I, j, and k by x, y squared, z. So partial cubed partial x squared partial z of phi v means partial squared partial x squared of partial z of phi v. So which means that then we need to start by getting partial derivative with respect to z of this function phi v. So partial z of phi v is the same as, now this term or this component with respect to z, we get 2x squared y squared z, and then I minus x squared y squared j plus 3x y cubed z squared k. So that's the first step. So remember now, this is x times x is x squared, y power 2 times y power 2. This should be 4. And then so this is also power 4. Cos 2 plus 2, loss of indices. So correct that mistake. So this is 4. This is 4. And then, so we have now partial squared, partial x squared of now 2x squared y squared zi minus x squared y power 4 j plus 3 x y power 3 z squared k. So this can as well be written as partial x of partial x of this same quantity, 2x squared y squared z I minus x squared y power 4 j plus 3x y cubed z power 3 z power 2 k. So when we work out what we have inside the curly bracket, so this will be given by partial x of so this part will give us 4x y squared z I minus 2x y power 4 j plus 3 y cubed z squared k. Then further, this will give us 4 y squared z I, and then minus 2 y power 4 j plus, actually this will be 0 because there's no x. So i.e. partial cubed partial x squared partial z of 5v is given by 4 y squared z I minus 2 y power 4 j. Now, which implies that partial cubed partial x squared partial z of 5v at the point specified 2 minus 1, 1, we get 4 minus 1 squared times 1 I minus 2 minus 1 power 4 j, which will give us 4i minus 2j. This is the final solution to that given problem. And lastly, number 3, given v is a vector 2xi plus 3y zj plus 5x z squared k, find 1 partial v partial x, 2 partial v partial y, and 3 partial v partial z. So here, solution will be 1 partial v partial x component you get 2i, y component is 0, j component is 5, z squared k. So which you can just write 2i plus 5z squared k. From on 2, partial v partial y. Now this will get 0 for x component because there's no I, there's no y. Here we get 3zj, and this will give us 0k, because there's no y. So this will be 3zj. Lastly, Ramon 3, partial v partial z. X will get 0. For I component is 0, there's no j, there's no z, plus 3y plus 10xzk. So which you can just write 3yj plus 10xzk. So that will be the solution to the problem 3 given. Now, once we have that, then that locks the end of those 3 examples that we were to discuss.